Do you know how to graph this function right here? If not, this video will help you with all the transformations you will encounter in Precalculus. It will help you graph them and identify them. Hope you enjoy the video. Okay, let's start with the basics. Let's start with the translations. Now, there are translations that go vertically, like this one right here, and there are ones that go horizontally, like this one right there. Now, how do you identify which is which? So you're gonna look for the parentheses. If you see that there's a parenthesis and that number is directly affecting the x, like it's happening right in this one, it's gonna be a horizontal translation. While if you see that there's no parentheses and the number is not directly affecting the x, it's affecting the answer, the y, it's gonna be a vertical translation. Now, the vertical translations are kind of easy. You can just okay, so if you got x squared plus 3, well, you just go 3 units up. So your graph would originally look like this, right? This is the normal x squared graph. But if you have a translation that's 3 units up, like we have right here, you go 3 units up in your coordinate plane, and you just start from there. And there you have it. This would be that graph. Now let's say it said x squared minus 3, it's pretty straightforward. You just go 3 units down and you start from there. Okay, so transformations get a bit tricky when you start to talk about the x. You see, what happens is, when you try to change the value for the x, you're kind of gonna do the opposite of what you think you'd do. For example, over here you see that there's a translation of 3 units, but it's gonna be 3 units to the right, even if it's negative right here. This is because when you do x minus 3 equals 0, and you try to solve for x, you're gonna get x equals 3. So this is telling you it's gonna go to the right. That is why when you have this graph in your coordinate plane, instead of going to the left, it's gonna go over here to the right. Okay, let's look at this one. F of x equals x plus 4 squared. Now, we have this plus 4, and we already established that you do the opposite of what this says. And the opposite of positive 4 is gonna be negative 4. So you're gonna start over here. Hope you understood that. Let's go to another example where we'll combine the horizontal translations with the vertical translations. Okay, here we have an example where we're combining both the horizontal translation and the vertical translation. Now, how do we establish what's the horizontal one and what's the vertical one? Well, that's easy. Okay, what's in the parentheses? This one right here. So this one right here has to be our horizontal translation, while this one that's outside the parentheses has to be our vertical translation. Let's put that into a graph. Okay, well, we know the easy one. This one means 4 units up. Okay, we're gonna start right here. But this one, remember, you have to do the opposite of what the symbol tells you. So if it's a positive, you're gonna have to go to the negatives. So our graph is gonna start right here, and it's gonna do just like that. Let's say you want to find at least 3 points of your values in this graph. Let's say you want to find this point, and this point. Well, to do that, you're gonna have to base it off of your original graph. Your original graph looked just like this. This point right here is in your origin. This is in -1, 1. And this point right here is in 1, 1. So we start at 0, 0 for our original graph. Now, let's go over here. And what was our translation for the x? It was 5 units to the left. So you're going to put in the equation, the x, minus 5, because it's the opposite. Remember, to solve, to know where the x is, you're always going to do the opposite of what you think it is. So it would be x minus 5 to find the value of x, and for y, it would be plus 4 because that's the translation you're doing over here. So y plus 4. Now, these are going to be your x and y values. So once you do that, you get 0 minus 5 and 0 plus 4. And what does that give you? It gives you minus 5, 4. And where's our first dot? Right there. Let's try doing it with 1 and 1. Well, we would just put x minus 5 again, y plus 4. This gives you 1 minus 5 and 1 plus 4. And the next value for our next point would be negative 4 and 5. Let's see if that's correct. Yes, because you move 1 to the right and 1 up. Okay, now let's look at this part of transformations. These are going to be our reflections. Now there are going to be reflections across the x-axis, like in this case right here, or there are going to be reflections across the y-axis, like here. The first thing you're going to notice is that we have negatives right here and right there. For a reflection to happen, you are gonna need negatives. If there's no reflection, you're not gonna see negatives. Once you see that negative, you're gonna look at which part of the function it is on. If it's not directly affecting the x, like it's happening right here in this one, well, it's gonna be a reflection across the x-axis. While if it's directly affecting the x, like it is on that case in the top, well, it's gonna be a reflection across the y-axis. Now, what does that look like? So we know that our normal square root of x graph will look like this. It will look something like that. Well, if we have a reflection across the x-axis, well, it's gonna look a little like this. While if you have a reflection across the y-axis, it's gonna look like that. You see? This is the y-axis. It's like a mirror, basically. Imagine like if you had a piece of paper, and this was like the coordinate plane was your piece of paper, and you folded it in half, that's what you'd get. But, of course, this is without the translation that I applied over here. If you were to actually apply those translations, this is how it would look like. You see, I applied the opposite effect of what you'd think of for the x, so it's now over here in the positive 4, and then after doing that, I did the reflection across the y-axis. Let's say you want these 2 points from either one of the graphs. Okay, so you know that our normal graph would look a little like this. For this graph right here, the reflection across the x-axis, you see that this is the only thing that's getting affected for the y, and this is the only thing getting affected for the value of x. So you would start at the point 1, 1. We already know the first point. It's going to be this one. Let's go for the second point over here. You start at the point 1, 1, right? What you do is for the value of x, you start with 1. And since it's minus 4 in the parentheses, you're going to put plus 4. What'd that give you? 5. And for y, you'd start with 1, and you'd apply that negative 1, which would give you negative 1. So that means that this point right here would be 5, negative 1. It would be right here. But something different happens for this one over here. Both transformations are being applied to the x. So you'd be multiplying negative 1 to the x and a plus 4. Now what do you do here? You just do PEMDAS, okay? So just minus 1 times the value of x would be 1 plus 4. And that would give you negative 1 plus 4, and that'd give you a 3. And since nothing happens to y, your new point would be at 3, 1. Let's see if that matches. 3 over here, and 1. Yes, that would be it. So these are the last types of transformations. This would be the stretch and the shrink. So if the number is bigger than 1, you're going to have a vertical stretch or a horizontal shrink. But if the number is between 0 and 1, you could either have a vertical shrink or a horizontal stretch. Now, how do we determine which one of the two it is? Well, if the number is directly affecting the x, we can determine which one of the two is being used because the number is either going to be directly affecting the x or it's going to be affecting the y value. To determine this, I did some examples. For example, over here for the horizontal shrink, you can see that it's directly affecting the x because it's inside the bracket. If it was outside of the bracket, it would look like this one. You don't even need the brackets for this one, and that would be a vertical stretch because it's not directly affecting the x, it's just affecting the value that you're gonna have as the result. So the y value. And you're gonna look for the stretch and the shrink. You're always gonna look at the outside number. Same goes for the vertical shrink and the horizontal stretch. It would be that a number between 0 and 1. In both cases, you just need to look for where it's located. If it's located outside, well, it's a vertical shrink. If it's located inside the brackets, well, it's a horizontal stretch. What do you think this one right here would be? If you said that it's a vertical stretch, you would be correct. That's because this 3 is outside of the parentheses, and it would be a vertical stretch and not a shrink because it's a 3, and you need a number bigger than 1 for it to be a stretch, and a number between 0 and 1 would be a vertical shrink. To graph this is the method I use. I get my coordinate plane, and this would be my normal graph. I have a point on 0, 0, and I also have a point on 1, 1. Okay, I would use those points right there. It would start at the origin because there's no translation going on. Now, for the point of 1, 1, how would I get this point right here for this new graph? Based on symmetry, you would know that our next point would be right there, and our graph would look a little like this. Now, it gets tricky again with this one right here. What do you think I have here? If you said I have a horizontal stretch, you would be correct. I have a horizontal stretch because this number is between the number 0 and 1. It's 1/3. So I would get a horizontal stretch. Now, how would I find this point I'd have here? Well, I'm going to use the same method I used last time, but I'm going to explain what I'll do. So I have the point 1, 1, right? And this only affects my x value. So I'm going to put 3 times x, and this is going to be my new x value. Why did I put the 3 there? This is because I need to do the opposite of division to know what my x value will be. What I mean by that is that if I see 1/3, I'm gonna have to multiply by 3 because that's the opposite of division. So I'd get 3 times 1 equals 3, and my new value for the point would be 3, 1. This y stays the same because I'm doing no translation and no effect to the y value. So this point would actually be a little more over here and 1. And notice how the graph would be really wide. For this one right here, this is a vertical shrink because I have a 3 over here. So to get the value I need in the graph, I would just multiply by 1/3. And the result I get here would be the value for x I need for the graph. So right here it would be 1/3 times 1 equals 1/3. And since nothing is happening to the y again, well, it would just be 1/3, 1. And notice how in horizontal shrinks, your graph will look like very stretched up instead of like really open like we had in the previous one. This one's really open, really wide, while in this one, in our horizontal shrink, it's just going really up. Okay, this is gonna be our last practice exercise. So let's identify what we have here. We have a horizontal translation 2 units to the right. We have a vertical stretch. We also have a reflection across the x-axis. And last but not least, we have a translation 4 units up. Let's figure out where the first point is gonna be. That's the easiest one to figure out. So if this is our coordinate plane, we see the +4, so it would be somewhere over here. And we have the -1, which would mean, since we have to do the opposite, we'd have to go over here to the 2. Our graph would start right there. In our original graph, it would be 1, 1. But for this one, the only x thing that is going to be changed is going to be this right here. This is the only thing that affects the x. So I'd do 1 + 2, because I have to do the opposite of what it says there. So it would be 3. Our x value is going to be 3. But for our y value, we would be multiplying -3 times this 1 over here plus 4. And that would give us 1. So our next point would be 3, 1. So our graph would be looking a little like this. And based on symmetry, our other point would be at 4, 3. And there you have it. That's how you would graph this one right there. Hope this video helped. This is just a basics on transformations. I could do another video with more examples, but this one was just trying to focus on what they are and how to identify them. Hope you enjoyed the video. If you want to see more math related videos, please consider subscribing, and goodbye.